Assalamualaikum and selamat sejahtera to Dr. Nur Aslina Muhammad Ismail and our fellow friend. For this assignment, we have been assigned to do Lajak Kuruih for F tablet. We are from Group F from Section 21 for Engineering Statistics. Our group member consisting of me, Nur Aslisa binti Jimbon, Leong Ying, Lee Kok Ming, and Muhammad Fauzan. For the introduction, Lajak Laku is a manufacturer that produces health supplement diet tablet called Lajak Kuruih. It produces at least 15 types of Lajak Kuruih tablet with different health properties. 200 sample observations taken at random from 3 production shifts run daily, namely morning, evening, and night. The sample data from the different properties which are wet, tensile strength, and relative density. For question have for question A, we will be describing and summarizing the sample data of Pilajakurwe F tablet, which produced in December 2021. We will be presenting the observation effectively in numerical, tabular, and graphical form. For the first numerical form, we will be doing the summation of data, which is for morning shift, the sum of weight is 26,155.99, and the sum of tensile strength is 537.10, and the sum of relative density is 6,611.80%. And for the evening shift, the sum of weight is 23,445.86 milligram, 475.60 for the sum of tensile strength, and 5,855 percentage for the sum of relative density. However, for the night shift, the sum of weight is 20,264.40, and the sum of tensile strength is 414.20, and the sum of relative density is 5,107.50. The average of data for the second table we will be doing is the average of data. For the morning shift, the average of weight is 348.75 milligram. Average of tensile strength is 7.16 megapascal. Average of relative density is 88.16. For the evening shift, the average of weight is 349.94 milligram, and the average of tensile strength is 7.1 megapascal, and the average of relative density is 87.39. The night shift, the average of weight is 349.39, and the average of tensile strength is 7.14, and the average of relative density is 88.06. The third numerical form, which is the numerical data obtained from the sample, the descriptive statistic containing of mean, standard error, median mode, standard deviation, sample variance, kurtosis, skewness range, minimum, maximum, sum, count, and confidence level at 95%. Secondly, for our tabular form, the first one is the frequency table for weight, range between range for 5, which started from 300 and 305 milligram and ended with 385 until 390. As you can see from this table, the highest frequency will be around the 345 until 350 and 355 until 360, which is 31. For the second tabular form, which is the frequency table for tensile strength, we decided to range it up for around 0.5. So as you can see, the frequency, the highest is from 7 until 7.5 megapascal. And the third tabular form, which is for relative density, we decided to range it for 3, which is 82 until 85 and ended with 94 until 95. As you can see, the highest frequency, which is around 85 until 88. Next, we have done for the graphical form. For the first one is the sum of the morning shift until the night shift, the highest value, which is sum of weight, followed by the sum of relative density and the sum of tensile strength. The second table, the second graph we can see is for the frequency of tensile strength. For this one graph, the highest value for tensile strength is range from 7 until 7.5 megapascal. The third graphical form we have done is the frequency of tablets weight. As we can see, the highest one is from 345 until 350 and 355 until 360. Last but not least, the graph for the frequency of relative density. As we can see, the highest one in this is from 85 until 88 percentage.
Next, for question B, present and comment on whether there is significant evidence that Lajak Laku F tablets produced do follow the distribution required by FDA authority, which is weeks of standard tablet normally distributed with mean 350 mg and standard deviation 40 mg. So for this question, we have to do goodness of fit test. And then for in the hypothesis statement, for rational, we have the weights of standard tablets produced by manufacturers follow normal distribution with mean 350 and standard deviation 14. And in the H1, we have the weights of standard tablets produced by manufacturers do not follow normal distribution with mean 350 and standard deviation 14. So next, in the test statistic, since we have the values of expected frequencies less than 5, so we have to be 2 times. And then in the last column, the total values for observed frequencies minus expected frequencies square divided by expected frequencies is 11.7852. This value also known as chi-square test value. So next, for the test statistic continuation, since all the values of expected frequencies is larger or same as 5, so we can proceed. And then K value, which is number of categories, is 11. And for the P value, which is the number of unknown parameters, is 0. Okay, that's for the decision rule. First, we have to find the degree of freedom, which is K minus P minus 1. So the value is 10. And for the critical point, for the chi-square with alpha value of 0.05 and degree of freedom 10, we get the critical point value is 18.3070. So we have to write the statement, reject H null if chi-square test is larger than chi-square alpha degree of freedom. And then this is the graph with the complete label. And then for the conclusion, since chi-square test value is 11.7852, less than chi-square alpha 0.05 and degree of freedom 10 value, which is 18.3070, then fail to reject H null. So we conclude that the weights of standard tablets produced by manufacturers thus follow normal distribution between 350 and standard deviation 14 at alpha 0.05.
For the part C, we need to determine the significance difference between the table weight. From the given data, we will be grouped into 3 categories, which is morning shift, evening shift, and also the night shift. Then, we will do a hypothesis statement. As you can see here, the null hypothesis, which is mu1 equal to mu2 equal to mu3. mu1 is known as morning shift, mu2 is known as evening shift, and mu3 is known as night shift. So, null hypothesis is there is no significance between the tablet weight from the different shift. Next, the alternative hypothesis is at least one difference, so it is a significance between the table weight from the different shift. To determine which is being rejected, we have to use ANOVA data analysis in the Excels to determine it. Now, after we use the ANOVA data analysis, we got 2 tables as shown here. The above table is about the summary of the 3 different shifts, morning, evening, and night. Their frequency, sum, average, and also the variance, respectively, are shown inside the table. As you can see, the table below is ANOVA table with 2 sources of variations, which is between group and within group. There are sum of square, degree of freedom, mean square, F distributions, p-value, and F critical value inside the table. So, after we got all the value, let's compare the p-value and the alpha value. Since the p-value, which is 0.8904, is more than the alpha value 0.05, the null hypothesis is rejected as well. Hence, we can do a conclusion here, which is there is no significance between the table weight from the different shift at a 5% significance level.
Next, I will present the question 4. The question asks us to determine the prediction of the tensile strength for such tablets and comment on the validity of the model for this prediction. So in this question, the study have indicated that its tensile strength depends on the relative density regardless of the production shift. So linearity regression model will be used in this question to predict the tensile strength at the given relative density of pure Lajak Kuruih F tablets. So in this question, the dependent variable is the relative density and the independent variable is the tensile strength. So from the analysis result from the Excel, we can get the value of correlation coefficient R equals to 0.8447, which is close to unity, and it implies that there's a strong positive linear relationship between relative density and the tensile strength. So from this table, we can get the value of y-intercept delta naught equals to 0.2617, value of the slope delta 1 equals to 0.07821, value of the t-test for delta 1 equals to 22.21, and the p-value equals to 1.17 multiplied 10 power of negative 55, and this all value will be used in the further calculation. So the simple linear regression equation will be used to solve the problem. So we just substitute the value we get just now into the equation. Then we will get the equation y equals to 0.2617 plus 0.0727821x. So after that, we need to predict the tensile strength at a given relative density. So we substitute the value of 60x, 74.3, and 80.1 into the equation. Then we will get 5.58, 6.07. 27 and 6.5263 for the tensile strength with the unit megapascal. So these 3 are the linear graph between the tensile strength and the relative density. So the next one is the validity of the model. So by testing the hypothesis about the slope delta, we'll test the linearity of the simple linear regression model. So the hypothesis statement is H naught delta equal to 0 and H1 delta not equal to 0. So the next one is the ANOVA approach at 95% of confidence level. So from the ANOVA table, we can get the p-value equals to 1.17 multiplied 10 power of negative 55, which is less than the alpha equals to 0.05. Then H naught is rejected. Hence, we can conclude that there's a strong linearity relationship between the pure Lajak correct F tablets reactive density and the tensile strength exceeds at alpha equal to 0.05. So there are some comments on the validity of the model. The first one is the correlation coefficient R equals to 0.8447, which is close to the unity. So as we mentioned just now, it implies that there's a strong positive linear relationship between the reactive density and the tensile strength. So the second one is the model is considered as a valid model because the p-value for the delta is 1.17 multiplied 10 power of negative 55, less than the significant level, alpha equal to 0.05. Hence, hash naught is rejected. So it implies that there's a strong linearity relationship between the pure Lajak correct F tablets relative density and the tensile strength exceeds at alpha equal to 0.05. So here's the conclusion. Based on the current data in the December 2021, the relative density values of 68%, 74.3%, and the 80.1% have the prediction of tensile strength of 5.58 megapascal, 6.0727 megapascal, and 6.5263 megapascal. The second one is the tensile strength depends on the relative density regardless of the production shift. And the last one is the strong linearity relationship between the pure Lajak correct F tablets relative density and the tensile strength exceeds at alpha equal to 0.05. So that's all our presentation. Thank you.